In this video, we'll generate the Chebyshev first-kind polynomials using Taylor-Maclaurin series sum and Linus polynomial regression. We begin generating the Chebyshev first-kind polynomial, which is the summation of a times 1 minus x to the power k, where k is from 0 to n, and a, the coefficient, is n times negative 2 to the power k times n the factorial of n plus k minus 1 all over the factorial of n minus k times factorial of 2k. So our values for n will be from 1 to 10 or greater than 0. So list of items from 1 to 10. So data validation, list of items 1 to 10. So these are our values of n. And our value of k is from 0 to n. So sequence of n plus 1, one column starting from 0, incremented of 1. So that if it's n equals 0, n equals 1, k is 0, 1. N equals 2, then k is 0, 1, 2. If n equals 3, k is 0, 1, 2, 3. N equals 4, k is 0, 1, 2, 3, 4. Now we can use the Taylor-Maclaurin series sum. That is array formula, series sum of the x value. So that is 1 minus x raised to the power k, where k starts from 0, incremented by 1, and the coefficient will be this range. So here we have the trend line equation, which is also the Chebyshev first-kind polynomial to the degree 10, and the trend line of the polynomial. Next, we complete the coefficients. So that is starting from the numerator. So array formula of n times minus 2 to the power k times factorial n plus k minus 1 minus 1. Enter. So that's the numerator. If this is empty, this should be 0. So we have to correct this. So we start with if if so if k is empty, it is empty, 0. Otherwise, calculate. Now that's better. So if this is empty, this should be 0. Now we continue with the denominator. The denominator has two parts. So we have the first part, that is factorial n minus k. N minus k. And then multiplied by the second part. Second part is, so that's a factorial, times 2 times k. So that's factorial of 2 times k. Factorial 2 times k. That should be correct. So at n equals 0 or n equals 1, So our trend line polynomial y equals x, so 1x. Now we'll calculate this regression coefficients using Linest. To do that, we complete the 1 comma x matrix. So here we have the 1 comma x matrix, which is array formula of the x values raised to the power 0 to 10. Now that we have the 1 comma x matrix, we can calculate Linest. So this is equal to Linest data y and comma data x. Enter. So at n equals 1, here we have the Chebyshev first kind polynomial y at n equals 1. This is equal to 1x. So 1x. At n equals 2, the Chebyshev first kind polynomial y equals negative 1 plus 2x squared. So negative 1 plus 2x squared. At n equals 3, the Chebyshev first kind polynomial y equals minus 3x plus 4x cubed. At n equals 4, Chebyshev first kind polynomial y equals 1 minus 8x squared plus 8x to the fourth. The rest is 0. At n equals 5, the Chebyshev first kind polynomial y equals 5x minus 20x cubed plus 16x to the fifth. At n equals 6, Chebyshev first kind polynomial y equals negative 1 plus 18x squared minus 48x to the fourth plus 32x to the sixth. At n equals 7, so our Chebyshev first kind polynomial y equals minus 7x plus 56x cubed minus 112x to the fifth plus 64x to the seventh. So that's minus 7x plus 56x cubed minus 112x to the fifth plus 64x to the seventh. At n equals 8, Chebyshev first kind polynomial y equals 1 minus 32x squared plus 160x to the fourth minus 256x to the sixth plus 128x to the eighth. At n equals 9, Chebyshev first kind polynomial y equals 9x minus 120x cubed plus 432x to the fifth minus 576x to the seventh plus 256x to the ninth. At n equals 10, our Chebyshev first kind polynomial y equals minus 1, negative 1 plus 50x squared minus 400x to the fourth plus 1120x to the sixth minus 1280x to the eighth plus 512x to the 10th. This completes the use of Taylor-Maclaurin series sum Linest polynomial regression to generate the trend line and the trend line polynomials of Chebyshev first kind polynomial.